Two events are dependent if the outcome of one event changes the probability of the other event. In a bag of 8 marbles, we have 3 red and 5 are yellow. 2 marbles are selected at random without replacement. Okay, and this is extremely important. That wording, without replacement, just means that when you choose the first marble, you're not going to put it back before you choose the second marble. If you did put the marble back before you chose the second marble, then these will be independent events when you choose the 2 marbles. But because it's without replacement, that means that the events are dependent. Because after you choose the first marble, you started with 8 marbles total. After you choose one, there's only going to be 7 left over for that second marble. So find the probability that both are red. So if you were to choose 2 marbles, both of them being red, you have to choose a red and a red. So a red first and a red second. So the probability the first one is red is 3/8, and means we're going to multiply. The second marble being red, well, now there are 2 red marbles left out of 7 total. So we started with 3, we assumed the first one was red, now there's only 2 red out of 7. Multiply those together, you get 6 out of 56, or 0.1071. So that's a pretty straightforward calculation. Okay, the next one, find the probability that both are not red. So to both be not red, what do you have to draw? Well, you have to draw the complement of red. So remember, that little bar over the event just means it's the complement. Another way to look at it in this case, because this is a very simple case, you only have 2 colors, red and yellow. So the complement of red would be a yellow. So you can also look at that as a yellow and a yellow. The only reason I wrote the complement of R each time is if you had different colors in there. So suppose you have like 2 blue marbles, 7 green marbles, and so on. Then you can't just say yellow and yellow because you have different colors. But this one was more basic than that. So you look at it as a complement of red. Well, how many of the marbles are not red? There's 5 of them out of 8. So the first marble not being red is 5 out of 8. If you're not replacing that marble, the second one probability is 4 out of 7. Multiply those together, you get 20 out of 56. 0.3571 probability. Okay, and then part C, the probability that at least one is red. And this is a little more complicated because to get at least one red could have been 1 or 2 red. So that's where you go through and you look at the different cases. To get at least 1 red, they could have both been red. Or the first one could have been red and the second one not red, or yellow in this case. Or you could have gotten the yellow first and the red second. So those are the 3 possibilities of how to get at least 1 red. So if you find each of those probabilities and add them together, so red and red is 3/8 times 2/7. And each of these individually here, the 3/8 times 2/7, is the same idea as the first couple examples. But now, because that event could have occurred, getting at least 1 red could have occurred in a few different ways, you have to add the probabilities together now. So you can go through and look at the second one is 3/8 times 5/7. And then the third one was 5/8 times 3/7. Okay, so you multiply each of those individually and then add the results together. And you end up with 36 out of 56, which is 0.6429. Okay, now I'll point out another way to look at that problem is similar to in the another video where I showed you at least 1, you can look at the complement of at least 1. And the complement of at least 1 is 0. So the probability of getting at least 1 red is 1 minus the probability of no red, or 0 red. So if you find the probability of 0 red, means that you had to get yellow and yellow, or not red and not red. So subtract that probability from 1, and you end up with 1 minus 20 over 56, which is the same probability, 36 out of 56.